Welcome back. Today, we'll talk about identification of materials 2. Under this, we're going to talk about identification of ceramic, plastic, and rubber. By the end of this lesson, you should be able to identify the properties of ceramic and glass, identify the properties of plastic and rubber. Ceramic is a clay that has been heated to a very high temperature so that it becomes hard. Ceramic is a clay. Please take note. Ceramic is a clay. So when you heat this clay to a very high temperature and harden it, we call it ceramic, and some other processes that it can undergo to make them look the way we see them in the market. What are different properties of ceramics? How do we identify a ceramic? Number one, ceramics are highly heat resistant. What does that mean? It means that they resist heat. Heat does not get to them easily. Are you with me? They are resistant to heat. If you heat ceramic and heat metal and in the same tune, the same temperature, you discover that the metal will be very hot compared to the ceramic. That's why when we want to build furnace, we'll use ceramic to build them instead of metal, because heat don't pass through them easily. They resist it, highly resistant. Heat don't pass through ceramic. So since heat don't pass through them, they are resistant to heat. They don't conduct electricity at all. Ceramics don't conduct electricity. Basically, that's why you see them used in transmission. They are resistant to corrosion. They don't corrode. Some corrosive chemicals don't attack them. Chemicals like alkalis, what we call bases, acids don't attack them. So if you pour an acid on ceramic, nothing will happen to the ceramic. If you pour an acid, pour a base to ceramic, nothing will happen to the ceramic. But if you do the same to a metal, you see that the metal will corrode. It will corrode the metal. So ceramics, they can easily be decorated. They are brittle. When you drop them on the ground, you hear that sound. Brrr, that's the end of it. They are very, very brittle. They will break. So if you have ceramic cup in your house, you have ceramic vase, you have anything, if it drops down, it will break. So that property is what we call brittleness. Ceramic are very, very brittle. You know, they are brittle. They break easily. So maybe mistakenly you are moving to your room or something, you're carrying a ceramic cup. If it hits the door, it breaks. It breaks. Identification of glass. Glass is a type of ceramic. All right? Glass is made from a mixture of sand, lime, potash, soda, and lead oxide in the appropriate ratio. When you mix this together and some other processes it can undergo, what we produce is glass. You know that glass is very, very transparent. Very, very transparent material. It's also resistant to heat, just as a type of ceramic it is, and so many other things that we do with glass. So how do we identify glass? Glass is brittle. It's resistant to corrosion. It's transparent. You can see through it. When you say something is transparent, it means you can see through it. You can see through glasses. You cannot see through ceramics, but you can see through glasses. You see? That means this ceramic must have undergone certain modifications, certain treatment to produce that kind of ceramic. Plastics, they are synthetic materials that can be formed into products that are usable to us by heating and molding and grinding. So these synthetic materials, all right, naturally they are from resins. Resins are from distillation of petroleum. That's where we get them. So plastics are majorly from resins. That's the raw materials that are used for the production of plastics. They are called resins. So when you heat them and mold them into any shape, we have plastic. How do we identify plastic? How do we identify them? How do we identify plastics? We're going to look at that, just now. But before then, let's talk about classes of plastics. We have two types of plastic. Number one, we have thermoplastics. We also have thermosetting plastics. Thermoplast plastics, they are the type of plastic that you can melt them and mold them into any shape that you want. Even after they have been produced as a finished product, you can remelt them and remold them. So this type of plastic that is not resistant to heat, that melts when heated, they are called thermoplasts. Example of thermoplasts include a nylon. Another example include the polythene, the PVC. PVC means polyvinyl chloride. And the polyethylene, they are all examples of thermoplasts. Even the cup you have in your home, plastic cups, when you heat them or mistakenly you use candle close to them, by the time you say Jack Robinson, that cup is melted. Okay, so that type of plastic that is not resistant to heat is called thermoplast. They are classified as thermoplasts. We'll have another type of plastic we call thermosetting plastics. Thermosetting plastics, they char at high temperature. They don't melt when you heat them. Rather, they char. All right? We have example of such plastic. They don't melt. That's what something you have to know. Thermosets don't melt when you heat them. Thermoplasts, they melt when you heat them. Examples of thermosets include the polyester resins, the epoxy resins, the bakelite, the formaldehyde, phenol formaldehyde, etc. You can have some of them, you can have them in some products like buttons. Button is a thermoset. The handle of your electric laundry iron is a thermoset. All right? The handle of some of your kitchen utensils, that your frying pan, that handle is made of a thermoset. It does not melt. No matter how many hours we have the frying pan on fire, they remain there. Even some of our kitchen utensils that have plastic handles, the handles are made up of thermosets. They don't melt. I know you iron your cloth. No matter how hot the iron is, no matter how many times it goes over the button does not melt because that button is made from a thermoset plastic. Okay, so what are properties of plastics? How do we identify plastics? Number one, they are resistant to corrosion. Number two, they are elastic. They are flexible. I've told you the meaning of elasticity before. Any material that the shape can change when you apply force on it, and when you remove the force, it returns to its original shape, is said to be elastic. Plastic have that property. All right? Yes. Plastic is light when compared to other materials, when compared to wood and metal and ceramic. Plastic is lightweight. They are flexible. That means you can have a plastic ruler You know, you can have your plastic fan, you turn it like this, you fold it, you do all of that. So it doesn't break easily. So it's flexible. All right? It's flexible. It's transparent. You can see through them. You can see through plastics. All right? They are attractive and they are very, very easy to clean. You can clean your plastic easily. No stress. So those are the properties of plastics, few of them. We have plastics applied in various products in our homes. We have plastic cups, we have in our kitchen utensils, you know, the knife, the handle of your knife is made up of plastic. It's a plastic you have there, yes. All right, it's a plastic. We use plastic in plumbing, we use them even in conduit wiring, yes. That pipe, that PVC pipe, it's a plastic. The switches in our homes, the switches we have, bang, 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 oh, light. They are made up of plastic. Car bumping, they are plastics. You know, coating of wires are plastic. Some basins, packaging materials, they are all products of plastics. Okay? This is what we're talking about. Some of you that like to build houses, you know, this is for your children. This is a switch we're talking about. This is for plumbing, of course. These are pipes that we use to channel either our waste to the soakaway. These are PVC pipes needed. They are all properties or products of plastic. You can see them here in large quantity. This is a plastic chair. This is a plastic stool. You know, this is a plastic trolley. We have a flask. You know, hope you are going to school. Your lunch box, that flask inside your lunch box is made up of plastic. It's a plastic you have there, okay? We even have plastic wardrobes now for babies. Plastic spoon everywhere. You can see them all there. Okay, rubber is another material we cannot leave aside. Very, very important in technology. Okay, rubber is a material that can be compressed and stretched. This is one of the things we know about rubber. That rubber actually you can stretch them. They are elastic. You can stretch rubber. For example, the rubber band. See the name, rubber band. The band is rubber because it can stretch. Okay, you see that? So you can also compress them. You can compress rubber, you can stretch them. That any material that does that is seemingly rubber. It's a material made of rubber. We have two types of rubber. We have natural rubber. We also have artificial rubber. Natural rubber are rubber that we obtain from rubber trees. Sometimes when you peel or cut the bark of this rubber tree, normally there's a liquid that gushes out of the rubber tree. We'll call it latex. All right? We'll call it latex. All right? That latex from the rubber can be worked on, you know, can be processed to form so many things that we have today from that rubber tree. So rubber from such means they are called natural rubber. We also have artificial rubber. That means rubber that are produced artificially by mixture of some materials to get rubber, especially from our petroleum sources. Yes, byproduct of petroleum, we can use them to produce rubber. Okay, now what are the properties of rubber? Rubber is elastic, it's water resistant, they are light and they can float in water, they are poor conductors, same thing as plastic. Plastic is a poor conductor of heat. Rubber is also a poor conductor of heat. We have different products of rubber. The car tires, they are produced from rubber. The eraser, they are products of rubber. The balloon, they are product of rubber. We have the dampers in cars, the damper rubbers. This glove here, used specifically by electricians, they are all product of rubber. Football is from rubber, you know. This boot you're seeing is from rubber. We have so many products of rubber. Okay. Now let us go to our ExamGuide app and practice questions based on what we have just discussed about rubber and other materials, rubber, ceramic, and plastic. The following are byproducts of ceramics, except A. Cups, flower vase, knife, plates, tiles. From the options, we have ceramic cup, we have flower vase, they are made up of ceramic, they are made from ceramic. A knife is not a product of ceramic, rather it's a product of metal. Plates, we have ceramic plates. The tiles, we have, they are ceramics. So the right option here is option C. Option C is not a product of ceramic. Let's study more examples and see. Number 43. The property of rubber are improved by a process we call elasticity, neoprene, synthetic, thermoset, vulcanization. Indeed, if you want to improve the property of rubber, you want it to be soft, the process of improving it is called vulcanization. So let's study more. Let's look at more examples on that. Which of the following is not a property of ceramic? Option A, brittleness, corrosion resistance, ductility, electric resistance, luster. Ceramics are brittle, they break easily. If you drop it on the ground, it breaks. Corrosion, that means they are resistant to corrosion. If you have acid or base poured on them, they will not react to them. Ductility, can we draw ceramics to wires? The answer is no. So ceramics are not ductile. They are resistant to electricity. That's why they are used as insulators in electric transmission. They are luster, they are shining. We have some tiles that you can see yourself while you're looking at them. So they show that shining property too, you know, but they are not ductile. So ductility is the right option there.